So in this presentation, I'm going to be going through the details and requirements for the ME 171 group project. Now this is going to be a large portion of your grade for this course. So this is something I'd really encourage everyone to start thinking about early on in the semester. So for this group project, there is going to be a topic that you're going to need to follow. And the title for this topic is the Design for Assistive Technologies. So what is the design for assistive technologies and how do we stay within that for these group projects? Well, what this means is that your design is going to need to be directly related to either rehabilitation science or assistive technologies. Now for assistive technologies, this can be rather broad. And what do we mean by these assistive technologies? Well, this could be something that could be broadly interpreted to include any device that can help people perform activities. So what are some examples of this? Well, this could include devices that aid people with disabilities. So that kind of goes back to your rehabilitation science right there. It could be something that helps people recover from an injury. Or it could be something that just enhances the physical or mental capabilities of healthy individuals. So again, this is a rather broad topic, and I want to give you the creative freedom to come up with some ideas that might be something that you're interested in as a hobby or a future career as well. Now, some of the activities considered here, these may range from those typically called the activities of daily living, or for higher function applications, they're thinking in terms of like sports or leisure as well. Now, one thing I do want to stress with this being a mechanical engineering course is that these projects that you come up with should primarily focus on the mechanical devices and not be solely based on your electronics or computers. So now I want to dive into a little bit more details and specifics for this group project. So again, the topic for this is going to be the design for assistive technologies. Now, for each of these projects, you must identify one of the following important goals. So only one of these three needs to be identified in the project that you choose to do for your group project. One, the first one here being a significantly novel design, something that's not common to an existing device. So again, this is new, novel, a new invention you're coming up with that doesn't relate and is not closely related to an existing device that's on the market. Now, the second option here is a design that's similar to an existing device, but you've changed something here to make it significantly less cost, available to third worlds, materials or components are changed for some reason. Again, it could be cost or it could be sustainability, any of those things. So it's a similar design to an existing device, but a tweak to that for, again, one of these reasons. Now, the third option here is a design similar to an existing device, but then adds a significant improvement to it. So you see something that's on the market and you say, this is great, but I think it would be even better if we did this or added this to it. So it could be something to deal with the aesthetics of it. It could be sustainability. It could be safety. It could be environment. So there is some relation between 2 and 3 right here. Basically, 2 and 3 are both taking something that is similar to an existing device, but then tweaking it for a new application or any of these things that we've discussed here. So again, whatever project you choose must meet one of these following goals, 1, 2, or 3. So one thing that I feel will be helpful for you in choosing a project is to maybe think of some different types of projects and some examples of those that fall under this topic of design for assistive technologies. So one of these topics down here might get you thinking about another project related to this that would still fall under this design for assistive technologies and be a part of one of those 3 major goals that we talked about on the previous slide right there, where it's either a completely new novel design or a tweak on an existing design. So some examples here. I've had some projects in the past where people have dealt with wheelchairs. It could be one that's an electric wheelchair for climbing stairs I've had students do. Again, focusing primarily on the mechanical components of that. I've had some people work on hand bikes. We're talking about assistive technology for rehabilitation. Sometimes these bed to floor chairs or chair to tub or other types of transfer devices, some stair climbers, walkers, prosthetics. I've had a lot of people work with different types of vehicles. I've had some projects actually related to farm machinery as well. So this is something where if you have an interest, a passion, this is your opportunity in these upper level classes to focus in on that. This might lead into a good senior project or a good place to work for an internship. A lot of people have done some projects related to outdoors equipment, different types of sporting outdoors as well, which leads to the next ones here for athletic or sports device. And then Again, just kind of going back to the assistive technology part of this, aids for activities of your daily living. And you can think of things as daily living, like what are you doing? Oh, washing dishes, washing clothes, cooking, cleaning, leisure, something to do with care of children or the elderly. So all of these hopefully will spark an idea for you to come up with your group a project topic. So we're going to break this group project down into individual steps. The first step of this group project is to formulate a suitable need statement and the design requirements. So within this, what you're going to do is you're going to write a short need statement. And within this, it's going to clearly identify the objectives and the functions of the design. Then from there, what you're going to do is decide on the design requirements for that specific application. Now, these include general statements on performance, reliability, cost, and manufacturability. You're also going to need to identify the target end users for this device. Now, we will be discussing throughout the semester as we continue on with this course a lot of these individual components that you're going to be using for this step 1. Now let's take a look at the second step. For step 2, this is going to be the retrieval of supporting information. So this is where you're going to start getting into that background research, determine what exists out there. So you want to find out what you need to know about existing designs that are already on the market. So we talked about those topics before that we need to follow. Is it going to be a new and inventive design that doesn't really exist or nothing similar exists yet? Or is it going to be a tweak on an existing design? So this is where you're going to find out what exists. So that's where you're doing that background research on these existing designs. And you're going to also at the same time look at the standards that need to be met. So this is something that's very, very important. Are there OSHA standards? Are there FDA standards? What are the associated standards that need to be met for the type of project that you're working at? Now, these might come from the industry, they might come from government regulations, or from the users or the company that produces them. They may have their own internal standards that need to be followed. And how do we determine where to go to look for those and how to interpret those as well becomes important. Now, also within this second step, you're going to be looking for information as you're doing your research on how your components are manufactured and the proposed methods for that manufacturing. So this is something, again, you're looking at the existing ones. Are these cast? Are these milled? How are they produced? And what are these methods? And look into some of the details on those methods as well. Now, when we say propose these methods, this might be saying, again, a tweak on an existing design of, hey, this is how this is currently made. I think there's a way to make it stronger by changing the manufacturing methods. I think there's a way to make it cheaper by changing how it's manufactured. All those type of things might come into play for your specific project. Now, how can we do our background research on this? Well, you can use the internet, use your textbooks or textbooks from other classes. The library has some great resources as well. And another great resource when you're talking about this is to actually contact some companies that exist for the existing designs, existing products that are on the market. Reach out to them, reach out to the manufacturers, and get some information. They might be able to tell you a little bit more than what's provided just on their website. So for our topic on step 3, this is where we're going to be looking at the translation of the design requirements to the design that you've chosen. So what does this mean? This means the design must include the overall design of the mechanical system. So again, we're focusing on that mechanical system, even though there may be some electrical components in it, some programming involved. We're not going to focus on that. We're going to focus on our design, our testing, our FEA, all that on the mechanical system. Now, the goal of this analysis is for you to justify the choices that you've made in your design. Now, these may be things included in geometry, the material function, and you need to prove that they will meet the design requirements and the objectives. Now, within this step 2, this is where you're going to start doing some actual modeling. So you should also express your design with CAD drawings. Now, I know some of you are also taking ME83 at the same time, your SolidWorks course, and I would encourage you, if that's something you're comfortable with, to use SolidWorks for this course as well, and maybe even combine the two projects. Now, our design must also include the general analysis of motion and loads of the overall device and the individual components. We'll get into some more details on how many components are required to do this analysis on. But again, this is something in general to think about. You're going to need those general analysis of motion and the loads for the overall device as a system as well as the individual components. Now, getting into the details, the design must also include detailed design for failure for at least 3 of these separate components that we discussed above of the system, per student on the team. This is something that we may tweak a little bit as the semester goes on, depending on the number of students in each group, but at the very least, each student within the group is going to be responsible for coming up with 3 separate components of the system that you're going to do this detailed failure for analysis on. Now, when we talk about analytical solutions, so these are going to be your hand calculations, similar to like what we do in the example problems in lecture, the homework problems, the exam problems. So these analytical solutions should be backed up and compared to the SOLIDWORKS finite element analysis. So you can see the limits of both of those. Sometimes you may find, well, I really can't get as detailed with my analytical solutions, and I may have to make some big assumptions and simplifications when I'm doing out these hand solutions as compared to what I can do within a SOLIDWORKS FEA. And you may find out within the SOLIDWORKS FEA, some of these really detailed solutions, you're not quite sure if they're right. You might want to go back to that general hand solution you have and compare those two. So this is going to require, you're going to both need the analytical solutions backed up with SOLIDWORKS FEA models as well. Now, one instance for these SOLIDWORKS FEA models, as I just mentioned, is when it gets complicated here for these complex, and what could be complex in terms of the loading and or the geometries. Now, I'm going to ask you also to take a look at the individual components to determine what is going to be important to investigate. So you can use the failure mode effects analysis, FEMA, to find out which components are going to be the most important to investigate. So if you have this whole system and you've got a lot of different components, but you need to pick out 3 of those components to really analyze right there, this may be useful in determining which components are going to be the most important to investigate. Now this course is going to build on some stuff you've learned in previous courses, and the case occurs here for this next step where I'm asking you to identify the material properties. You've seen this before, maybe in your ME 124 lab, maybe you've also seen it in ME 14 or ME 101 classes right here. We're going to take a look and identify the material properties that are going to be important in order to, again, meet that design requirement. Now another big thing, even though we list this in step 3, this is something you want to think about right from the beginning of your project, is safety factors. So you want to show how safe your device is, and use these different safety factors to show that. So the last step here is, again, I just want to reiterate that this should be a mechanical system that we're dealing with here, so you don't have to go into considerable amount of detail as far as the electronic systems, the controls, the sensing and intelligence of the systems. I want you to primarily focus on the mechanical design. So now this brings us up to our step 4 in the process. So within step 4, you're going to be beginning the write-up. So within the write-up, you're going to be using the outline that I've given you to build your proposal. Now this is going to include a discussion on the costs, standards, manufacturing, and sustainability. Now one thing I do want to stress here is that you need to leave time to mesh the writing styles, terminology, and quality for formatting among various contributors. And this is something that's important. And this is going to continue on past just this course. You may be writing research papers, you may be writing a conference paper with a team, or maybe even a proposal, a grant proposal, with a team of different engineers, and you need to make sure it all flows together and there's not different writing styles throughout. You are consistent with the terminology, you're consistent with the units you're using throughout the entire report. So this is something to think about as you begin your write-up, having maybe one person's doing the background section, one person's doing another section, one person's doing the conclusion section. Even though you might have individuals writing individual sections of this, they all need to flow together. And again, make sure you mesh the writing styles, terminology, quality, units, and all of that for all the different members of your team. So now I want to take a look at the milestones and due dates for this project. So again, this is to help keep you on track and time management for this project. So the first milestone is going to be on February 15th. And this is where you're going to form your teams, come up with a team name and a list of your team members. And this is going to be submitted to Blackboard as an assignment. Now you should have 3 to 5 members in each team. Your second milestone is going to be on Tuesday, March 1st. And this is where you're going to submit your white paper. This is going to summarize your decisions related to step 1. And this again is going to be submitted via a Blackboard assignment. Then your third milestone is on April 5th. This is where you're going to submit a 5-page. This is that 5-page outline presenting your work, and this relates back to steps 2 and 3. This is going to be, again, submitted via a Blackboard assignment. Your fourth milestone is on April 21st. This is where you're going to submit your final design reports. This relates to step 4, and again, this will be submitted via a Blackboard assignment. And the fifth milestone, this is going to be your final project presentations, which will be presented through Teams, and these are going to be on April 28th, May 3rd, and May 5th. So now I want to take a look at a little bit more detail related to this project, and in particular, let's take a look at the write-up. So for the write-up format, what this is going to include is you're going to have an introduction, then you're also going to have a statement of need, how the design meets the criteria, then you're going to get into the actual design. Within that, you're going to talk about the design overview and the need statement, talk about performance, reliability, and those safety requirements. So again, you can see this is happening right from the beginning, talking about that safety. Then you're going to get into the component overview and material selection. From there, you're also going to talk about within the design the individual detailed component analysis, talk about the associated cost requirements. Again, there's a lot of things that go into that we're discussing throughout the semester. Then you're going to look at those industry standards, and again, these may be related to the government regulations. Talk about the manufacturing requirements related to the type of manufacturing you're choosing to do, and the sustainability requirements as well. Then the next step in your format here for the write-up is going to be your conclusion, future directions, and your feasibility discussion. And at the end, also make sure you're going to include your references. So this is a real broad overview for that write-up format. Now, as you're getting started with this group project, one thing that's very important is to have a plan. Going in blindly to a project like this that has this much different things going on can be overwhelming. So I think it's a great idea to start off with a basic plan. Within this plan, things you want to discuss are going to define what needs to be done. Then once you understand what needs to be done, then you can assign different people to different aspects of the project, such as research, write-up, FEA, CAD design, all that there. But understanding what needs to be done, and then taking a look at each individual skill sets and deciding, okay, so-and-so might be great because they have a lot of experience with SolidWorks. Or I know that another person in this group really has done a lot of actual grant writing or project reports. I know they'd be really great at starting the write-up portion of this. So dividing the tasks for after you've identified what needs to be done with each individual within the group. Now, one thing that I do want to mention with these group projects is there is going to be a peer review. We're going to review your teammates as well as yourself, and this is going to go towards a component of your final grade. This is to ensure that everybody is contributing. So we talked about identifying what needs to be done and assigning people to those tasks. Well, if the person who was assigned to do the SolidWorks modeling in the FEA, is out sick or busy with another course or another project and they don't pull their weight on that, this is the opportunity to let everyone know what the contribution levels for each of the group mates through these peer reviews. So please do make sure that you dedicate the time that you need because your whole group is going to depend on you. And again, this carries on for outside of this class. It gets into your future, whether you're going on to grad school and you're doing these grant writing, if you're going to writing conference papers, journal articles, where you're working with a team together, or maybe if you're going into the industry and you're working with a team of engineers, and everybody's got their task, their job that they need to do, but other people are depending on your component, what you're working on, in order to do theirs. So this is something that's going to carry on. That's why I think it's important to keep yourself accountable for your responsibilities within this. So next thing I want to discuss is the evaluation criteria for these group projects and reports. So within this, equal weight is going to be given to the categories of technical competence, sophistication, style, and the clarity of the write-up. So style and clarity of the write-up, that kind of ties back when we talked about the groups and having this thing be a coherent report. So as I'm reading through this, it seems as if one person wrote it. You're not changing terminology. It's easy to read through and understand what's going on. You're using and maintaining the same style of writing, the same units throughout the entire report. We're also going to be looking at the technical competence. Did you do your research? Do you know what you're talking about for this report here? How sophisticated is this? Did you just do something really simple and really didn't get into too much technical detail with it? All you did was you made a round ball that rolls. We're going to grade that in there. So the sophistication level, this is something that's actually quite important to discuss as you're thinking about your group projects, because you don't want to make it so complicated and so sophisticated that you don't have the time in the one semester to really get in and do what needs to be done, but you don't want it so simple that you haven't really put any thought into the project. So find that balance between that for the sophistication level for this project. Now, as we're grading, again, we are going to use these peer reviews as part of your grade. So this is allowing us to take those peer reviews into account and change the grades of the individuals within the group based upon the contribution level of each individual. Now, another thing to keep in mind with the write-up right here is proper citation of the books, journal articles, or in this case here, a lot of websites are talking to individuals at the companies right there, and how to properly cite those in order to avoid plagiarism and to give credit where credit's due from where you got the information. UVM Library does provide a great resource here called Citations Matter, so I'd encourage you to take a look at that as you're beginning the citation in your references. So what I'd like to do now is to go through a clarification and overview for this final group project. Now, the intention for the structure of this project was to break it into 5 separate parts. And the idea behind these 5 separate parts was to help with time management throughout the semester. So the idea being to keep everyone on track with these set milestones for the completion of the project. Now, I've noticed without these milestones and the separate parts, sometimes things get pushed off and pushed back as you get busy with other classes, exams, homeworks, and all of a sudden the end of the semester comes up really quickly. And you realize, oh wow, I have so much to do for this group project, which is a large portion of my grade, and I really haven't started. You tend to rush and not do as thorough of a job as you could. So with these milestones, I'm hoping it'll help keep everyone on track and help with time management. And again, the whole point of this is to encourage students to avoid waiting until that last minute to complete the entire project. This is your opportunity to really showcase what you've learned in this course, previous courses, related to things that you're passionate about, projects, work environments. Maybe you're working for a company doing an internship and they have something that's related to this project. This is your opportunity to really put this into a project and tie everything together. So I really want to encourage you to get started early and follow these milestones throughout the semester so you're not waiting until the last possible minute. So as we continue on with the clarification overview for this final group project, I want to now relate our milestones to those 5 steps. So the first milestone is going to be on February 16th, and this is where you're going to be forming your design teams, coming up with a team name and a list of your team members. And you're going to submit this as a Blackboard assignment. As a reminder, each team should have 3 to 5 members. The second milestone is on March 1st, and this is where you're going to submit the 1-page white paper summarizing your decisions related to step 1 as a Blackboard assignment. Then your third milestone is on Tuesday, April 5th, and this is going to be the 5-page outline that you're presenting your work related to steps 2 through 3. Again, this will be submitted as a Blackboard assignment. The fourth milestone is going to be where you submit your final design reports, or step 4 in the process. And finally, the 5th milestone, which is going to occur on April 28th, May 3rd, and May 5th at the end of the semester. This is where you're going to give your live presentations through team for your group projects. So, in summary, Part 1 goal is to get everyone to create their groups. The Part 2 goal is to establish a project idea. The Part 3 goal is to create this 5-page outline covering steps 2 and 3 in the project description. And this was meant to help you get everything organized and completed for the modeling and failure analysis portion of the project. And Part 4 goal is to complete the project and to put everything that you had already completed into the correct format that was given in that project description. Now, summary here, step 4. What you're going to be doing in step 4 is the write-up. Using the outline that we discussed, you're going to build your proposal, include discussions on cost, standards, manufacturing, sustainability, and again, leave that time to make sure at the end when you submit the report that you've meshed together those writing styles, terminology, units, quality, and formatting for all the various contributors within your group. Now, a thing to note is that for this outline, the grader will be checking you've clearly presented your work to meet the requirements outlined in steps 2 and 3 in an outline format. So how will this be graded? Here's the grading rubric that the grader is going to be using for the final project submission. So below, we can see this grading rubric. This is something you'll have from the beginning of the semester, so you'll understand how you should write your report and how things will be graded. Again, this will be used by the TA for grading your final reports. These are submitted through Blackboard, and this rubric is built into Blackboard for this assignment submission. So please read through this very carefully and make sure that you cover all of these areas in your report. It's given to you right here with descriptions of what we're looking for this. So as long as you read through this carefully, you should know exactly what should be included within your report for the final project. So you can see the first thing is your introduction. 5 points associated with your introduction. Number 2 is the statement of need and how the design meets the criteria, and this is going to be 5 points here, and you can see over on the right we have a description of what this is, some comments related to that statement of need. Then you have your design. You can see the design, I've broken this down. We talked about this earlier, and we've broken it down again here in the rubric. So the design, you have the design overview and statement need, 10 points. Performance, reliability, safety requirements, are those included? 10 points. Component overview of material selection, another 10 points there. And again, any detail related to that's going to be over here in the comments. Individual detailed component analysis, you can see this is 50 points. So this is something, again, it's very important in a large part of the grade for this project right there is those individual detailed component analysis. Then we have 5 points associated for your cost requirements, 5 points for the industry standards and government regulations, 5 points for the manufacturing requirements, 5 points for sustainability requirements, 5 points for your conclusion, future directions and feasibility, and 5 points for the references. And then I'm leaving a bonus 5 points. Did you really put in some extra effort? Did you go above and beyond there? So there's a possibility for a bonus 5 points right there. So this total grade for this final group project submission will be out of 120 points. So now we're going to wrap up by summarizing that write-up format again. So again, you're going to have your introduction, you're going to have your statement of need and how the design meets one of those 3 criteria we discussed. We're going to have the design section broken down in these individual parts here, A through H, that we just discussed in that rubric. Then you're going to have your conclusion, future directions and feasibility, and your references. So this is going to be the format for your write-up.